Hello, I'm Arthur. Welcome to my lab. Here's an interesting thing that I picked up for a few pennies. It's a solar-powered flashlight. So here's the solar cell, and it charges the built-in battery. And here's the business end of it, flashlight. You turn it on, and you get the light. Except you don't get a whole lot of light because the battery is pretty much discharged. So let's take a look at what's under the cover here. And I'm cheating a little bit. I'm recording this video backwards. I've already recorded the part where I look inside of this thing because I already had it taken apart before I've started recording the video. So I already know what to expect. But here's what it is. This is the cell that powers this device, and because this is a solar powered device, this cell is being recharged. But some dummy decided to put a regular CR2450 cell in this flashlight, and CR2450 is a single-use cell. It's not a rechargeable cell, and that's why, I don't know if you can see it, but it's actually swollen. Let me see if I can bring it closer to the camera. This cell is swollen because it's been charged and it's not supposed to be charged. So there are cells that are rechargeable. I'm forgetting their name. They're something like CRL or something like this, 2450. So the numbers are the same, but the letter designation is different to indicate that it's a lithium rechargeable cell, which this one isn't. So I've ordered some rechargeable cells, and then I'll be able to pop one in here and charge it, and then this device should be back to business, should be fully operational. But until then, let's see what's inside of this device. I'm going to take it apart, or actually I've already done this, and I'll show you what I found inside. After I have removed the rubber feet off of the case, I was able to reveal the 4 screws that hold the case together. And here's what's inside of this solar cell powered flashlight. Here's the battery and the cover for it. This is the bottom cover where the battery goes and where the holes for the screws are. And this is, well, I'm surprised to see this. I'm not sure what this is. I was hoping that there would be some sort of LiPo cell inside that would actually store the charge, and that this battery, which I saw that it was a regular CR2450, I was hoping that this was just a backup for when the battery gets depleted. But this does not look like a battery. I think it's just a piece of metal, so this thing feels a little bit heavier, which is ridiculous that they're wasting space for this. They could have put 2 cells in here or put a LiPo battery in here for more storage. So the storage of this flashlight, the energy storage, is limited to capacity of this battery, which is not a whole lot. So here are the contacts for the battery and some wires from the cell, the solar cell, and the battery going to the circuit board. And that drives the LEDs. Here's the switch. So that's pretty much all there is to it. Excuse me. That's all there is to this. Not a complicated circuit. And once I get a replacement battery, I'll be back in business. The replacement battery arrived several days ago, and I popped it into this flashlight to charge it up, because that's what you really need to do first thing when you get the battery. You need to charge it, otherwise you create the memory effect in the battery, and that's not a good thing. So after a few days of charging, let's see. I just put the battery in this flashlight and then put it by the window. And let's see what happened over those few days, whether the battery charged to some reasonable rate. And this is what you should be using in these things. This is, I wonder if you can see this. This is a rechargeable version of this cell. I'm trying to find best angle so you can see the number on this cell, but it's LIR 2450, not a CR 2450. So the LIR is the rechargeable version of this cell. So let's see what voltage it reached after a couple of days of sitting by the window. 4.0 volts. This cell should really be at 4.2 volts, so I'm not too happy with this. I'll turn on this flashlight for just a brief moment and then let it charge some more. What I could actually do is hook up this battery to my lab power supply set to 4.2 volt, and I've looked up a data sheet for a smaller battery like this, the 2032, and that one is supposed to be charged at 17 milliamps. This being a larger battery can probably be charged at a little bit higher current, so I could limit my power supply's current to, let's say, 20-25 milliamps maybe, and set it to 4.2 volts, and then let the battery sit like that for a little while and charge up. But let's just pop it in for just a brief moment and see what happens when I turn on the light. Well, nothing. That's a disappointment. I was really hoping that I would get some light from this thing. Did I break it while taking it apart? I don't know. Either that or it's not making a good contact, so let's check it out. Let's try to power this thing from my power supply and see what happens. I've hooked up my lab power supply and I set it to 4.2 volts. Let's see, 4.2. And let's see what happens when I turn on this flashlight. Sure enough, it works. Works nice. Let's actually, while we're playing with this, let's see how much current this thing draws. So we're switching to amp mode. Turn on the light. What am I doing wrong here? Oh, I'm on 10 amp range, so I need to flip to this one. Here we go. 95 milliamps. So I could actually switch to milliamp range. Go back here. Here we go. 90 something milliamps. Around 95 milliamps. So that's the current draw. So why did this thing not work off of the coin? Is it not making a good contact? Because if we measure the cell, we're getting 4.0 volts. So let's see, if I reduce the power or reduce the voltage to 4.0 volts, will I still get the light? Alright, close enough. Let's try to power this thing. It works. So, did I get a funky battery? Is it just too weak to power this thing? How do we test this? I can connect my probe to the cell like this and touch And here we go. It works. Didn't make bad contact. So 78 milliamps from the cell. Let's see. Yeah, it's just not making, I think it's just not making a good contact. That's what it is. Which is weird. And the positive seems to be making good contact. So I guess it's the negative that's acting up. Let me try to bend it up a little bit. Well, this should work. What's going on here? That's funny. See, it works. So maybe this battery, after sitting for all these days in the flashlight, didn't even get charged at all because it wasn't making a good contact. So now I am going to hook it up to my power supply and limit the current and try to charge it up before I use it again. But also I'll have to figure out why it's not making a good contact and why it's not powering this flashlight when it's sitting in its holder. Well, for completeness' sake, let's just put the cover back on, see if that somehow makes any difference. It should not, but let's just give it a try. No, not really. Oh, here we go. Okay, so was it a problem with the switch? That's strange, but okay, here we go. It works. It powers, it turns on. I'm still going to charge this cell just to make sure that it is fully charged, but here you have it. Instead of the CR cell, you need to put a lithium rechargeable cell in these things, and then the cell shouldn't swell and should work just fine.